All right, good afternoon, everybody. My name's Kevin McGrail. Today, it is my distinct pleasure to introduce Lars Eilebrecht. He's going to be talking about securing communications with the HTTP server. And so without further ado, let's bring Lars up.
Thank you very much, my pleasure. And most importantly, thank you very much for letting me borrow your laptop, because apparently mine didn't work with a projector. So just a quick slide about myself. My name is Lars Eilebrecht. I work as an independent IT consultant, typically IT security consulting. I'm based in London. In terms of Apache, I've basically been involved with the Apache web server since 1996, co-founder member of the ASF. And given my interest in IT security, I'm also involved in the ASF security team. This presentation is about securing communications. That means TLS, HTTPS. This talk is intended intended as an introduction. It's intended for beginners. I don't want to go into advanced configuration, how to set up specific client certificate authentication or anything. It's more about the basics, because in my work, I found that even seasoned system administrators sometimes get this wrong because they don't understand what exactly they are doing. Yes, it may work for you. Maybe your server is correctly answering HTTPS requests, but it is very easy to get things wrong if you don't exactly know some of the basics. So I'll try to go through this reasonably quickly. If there are any questions, feel free to ask. I hope I have a few minutes at the end for Q&A. So we are talking about HTTPS. We are basically living in a world where we are heading towards HTTPS becoming the default for everything. Browsers will or have already started to penalize plain HTTP setups, where the browser tells you in a more prominent way, this connection is insecure. So HTTPS, it's basically plain HTTP over TLS, over a TLS session. You get three important things by using HTTPS or TLS: confidentiality and data privacy, which means no one can read your data. The communication between the client and the browser, the client and the server is protected from eavesdropping, and only the intended recipient can read the data. You get authentication. The browser, the client, authenticates the server. And optionally, you can configure your server as well to authenticate the client as well. Last but not least, data integrity, which is another bit. It's not just that the communication is encrypted. You can also be sure that no one has tampered with the communication between client and server. Quickly through some abbreviations and naming conventions or names. When people talk about TLS certificates, or when they talk about HTTPS, actually it's all X509 certificates. That's actually the name for the ITU technology standard, which was created in 1988 for PKIs, public key infrastructures. The common terminology you are confronted with is CA, that's the certification authority. So that's the place to which you would send a so-called certificate signing request and have a public or a commercial CA issue you a certificate. Eventually, a certificate may have to be disabled or revoked, and every CA is required, as per the PKI guidelines and requirements, to maintain a so-called certificate revocation list, which is basically a text file that contains signed information about which certificates have been revoked. I get to that topic later on a slide. When you deal with not just Apache configuration, but any type of TLS or HTTPS related configuration, there's typically two file formats or file types that you come across. One is so-called PEM files, and the other one is P12 or PKCS files. Apache wants files in the PEM format. The main difference is that P12 files is basically a single file that contains one or more certificates and or private keys in a single file. When it comes to PEM files, it's either a file that contains one or more certificates, or it's a file that contains one or more private keys. PEM files look like this. You may have seen that before dealing with certificates. And basically, it's just the base64 encoded format, or the underlying binary format are so-called DER files, distinguished encoding rules, AS1 values, doesn't really matter. Basically, what you can remember is DR files are the binary format, and PEM files are the base64 text files that Apache wants when you configure things. PEM files, because you have different files, commonly used file extensions are .key for the private key, CRT or CER for the actual certificate, and then CSR, which would be the signing request initially. But again, Apache itself doesn't really care about the file extension. It only cares that you have a PEM file. So what's a certificate? I've been talking about private keys. So this whole topic is obviously private public key encryption. You have the private key when it comes to your server configuration that sits only on your server, and the public key is something, well, that's been given to the clients. And a certificate is essentially a public key plus some metadata. And then you give that in the signing request to the CA, they add a few more bits and pieces to it, and then give that back to you in the form of a certificate. The most important, I wouldn't say the most important, but the metadata includes important information such as who is issued the certificate, how long is it valid for, and most importantly, the subject. The subject of a certificate, so a certificate isn't specifically tied to web infrastructure or servers. It can be issued to an individual. For example, the subject could be in relation to a person, to an individual person. When we deal with servers, obviously, it contains the host name. So that's the so-called common name. So the subject of a certificate is a list of identifiers. Typically, you find at the very least the so-called CN, the common name, as part of that subject, but it can contain additional information depending what type of certificate has been issued. At the bottom, you can see an example how this may look like. It may contain the company name, it may contain the country, etc. But typically, at the very least, you have a host name in there. In the case of a single host name, it's the fully qualified host name of your website. There's a special case that's defined in the SSL and TLS standard, which is a wildcard domain that you can add to a certificate. Clients treat this in a slightly different way. Basically, they would accept the very same certificate for every host name under that domain and for the domain itself. So for example, in this case, star.example.com works if you type in something like example.com into your browser. So in addition to single domain certificates, wildcard certificates, the main certificate type, so to speak, that you get these days are so-called multi-domain or SAN certificates. The abbreviation comes from the X79 extension that's called Subject Alternative Name, and that's basically a list of one or more host names for which the certificate is valid. Wildcard certificates are useful, but also a bit of a security risk, depending how many servers and hosts you have under a given domain. A SAN certificate allows you to limit this to just the set of, let's say, virtual hosts or domains or host names that you want to serve with that particular server or cluster of servers. Another special type of certificate are so-called extended validation certificates. Essentially, they contain a separate flag that tells the client, especially the browser, that this certificate has gone through, well, extended validation, which is basically the CA charging you more money for doing a little bit of extra work in terms of making sure that you definitely own this, this domain, that the company has been validated properly and is the authorized owner of this domain. You probably have seen this on some websites where basically it shows the company name in the browser bar. Typically it's green, depending which browser you're actually using. If we have time at the end, feel free to ask about this again, because I have a bit of a, I'll say, cynical view about EV certificates. I think they are not that useful, and to some extent just allowing CAs to make more money, but that's just my opinion. So obviously one way to get a certificate for your server is you can buy one from a commercial CA. You can pay for an EV certificate, sometimes actually up to more than 1,000 euros per year. You can get domain-only validation certificates for a few euros. Obviously, you can also create your own certificates. You have things like the OpenSSL tools or other tools. You can set up your own little PKI within an organization, maybe for like a test PKI for your non-production environments where you issue certificates yourself. Another very good option these days is simply getting a free certificate from a proper CA that works in basically all browsers and clients these days, which is called Let's Encrypt. It basically is a fully automated process. Typically it takes like, I don't know, a few seconds or less than a minute or a couple of minutes to get a certificate issued by the CA. And it only validates that you own the domain or that you have ownership of the domain itself. It's completely free of charge. Certificates are issued for 90 days, and you can renew them as often as you like. This whole CA service is provided by the Internet Security Research Group, which is a non-profit organization. They launched about 2 years ago, and it's been really popular. I use it for some of my own servers as well. If your browser, so why do we actually need to care about a CA? A browser or any client comes with a set of predefined and trusted root CAs. So the browser needs to figure out, here's the list of, depending how many your browser comes with, here's a list of all the root CAs I trust. There's a server certificate. If the browser is able to figure out that this certificate has been issued by one of the trusted CAs, everything will work fine. Otherwise, it will show a warning that looks like this. This is an example how this looks like in Firefox. You may also sometimes see this if there's some misconfiguration on your server. In many cases, I've seen this is in relation to misconfiguring so-called intermediate certificates. It's not very common that a CA would use the actual root certificate that's in a browser to directly issue server or client certificates. They usually have different levels of intermediate CAs, intermediate certificates. And when you configure your server, you are required to make sure that all necessary intermediate certificates are included in your configuration. Otherwise, the browser isn't able to determine that certificate chain, that chain of trust, and you will see an error message like this. The server client certificates in documentation is sometimes also referred to as the leave or end entity certificate. Let's talk about SSL TLS quickly. SSL was the original name, Secure Sockets Layer, for the protocol developed by Netscape back in the 90s. Basically, SSL nowadays, V2, V3, is considered deprecated and is insecure and should not be used anywhere anymore. If you're still using it anywhere, make sure you get that sorted out. TLS 1.0 and 1.1, they are still kind of okay, but really not recommended to be used anymore. So basically, going forward, everything that you set up should at the very least be TLS 1.2 and 1.3, which was just, I think, last month approved by the IETF as a new standard. So in general, when people talk about SSL certificates or TLS certificates, what they really mean, it's an X509 certificate, and I'm going to use this with TLS and HTTPS. Before I continue with the actual Apache-related configuration details, any questions so far? Does that make sense? Was it too boring? You already knew all of this? Okay. Yeah.
Yeah, hold on a second. Let me bring you a microphone.
So about this chain,
yeah.
Could you mention something about the validity of this chain, how it works in a couple of simple sentences?
Yeah, so basically, the root CA, that's the top level certificate that a certification authority owns. And they typically have they don't issue server certificates directly, they issue other CA certificates, they're intermediate CAs. Maybe use different companies, there's different setups for each commercial CA. So basically the root certificate issued the intermediate certificate number 1, and you may have several layers of issuing these certificates. At some point, let's say you have intermediate certificate number 3 in that chain, that's the actual one that was used to issue your server certificate. So the browser, I get to this in the configuration later. So basically, in your configuration, you would submit or configure your server certificate plus 1 or more intermediate certificates, and this is sent in the handshake, in the initial setup of the connection to the browser, to the client. And together with that, the browser is able, okay, I can find a chain of trust that leads to one of my trusted certificates, and then the browser is like, okay, all good, I trust this server certificate. Does that make sense? Yes. Okay, cool. Oops, where am I? Okay, mod SSL, Apache. It's basically been included since Apache 2.0 in the default distribution. It is based on OpenSSL. There are various SSL libraries or TLS libraries. OpenSSL is being used for the Apache module. It still supports SSL v3. However, as I said, do not use that. It's considered insecure and shouldn't be used anymore. It supports TLS up to version 1.2 in the stable 2.4 release of Apache. 1.3 has just recently been added to a development version of Apache. It requires OpenSSL 1.1. Obviously, TLS 1.3 has a lot of security benefits, should be used as soon as possible. Browser companies, Chrome, Firefox, etc., have or are about to start enabling 1.3 in the browsers, but it will still take a while before you have a sizable, let's say, market share of people coming to your site using or expecting 1.3. So at this point, 1.2 is still the main protocol that you want to use. So 1.3 will definitely be in Apache 2.6, the next stable major release. I don't really have or there isn't really a timeline for this at this point. I'm assuming, again, there's no, at least I'm not aware of any plans to do this anytime soon, but I'm expecting that at some point someone will backport this and make it available in a future 2.4 version of Apache. The first step in making sure this all works is you need to make sure you have the right modules enabled. Apart from the SSL module, you need to enable a caching module. There's the SHMCB, Shared Memory Cyclic Buffer module, which needs to be enabled because you need that for configuring session cache for SSL. If you use the default or the source distribution of Apache, there's an example file or default configuration for SSL, for the mod SSL configuration. However, if you use an Apache package from a Linux distribution, this probably looks a little bit different, and you probably don't have to worry about the module configuration that probably has already been taken care of. I get to that in a moment. First important configuration, I talked about the certificates before. You need these 2 PEM files, server certificate and the key file. With the key file, you should make sure that the key file itself is only readable by root on your server. It shouldn't be readable by the Apache user that's configured in your Apache. Most important step after that is you want to enable HTTPS for 1 or more of the virtual hosts, and you do this by defining SSL engine on inside your virtual host section. Typically, you want the default port for HTTPS, which is 443, so you need to make sure you have a listen statement to make it an HTTPS virtual host. Going back to the intermediate certificates, I already mentioned that briefly earlier. So that SSL certificate file directive that contains your server certificate, you have to put any additional intermediate certificates. Typically, you go to the documentation from your CA, whoever issued your certificate. They will tell you, here's 1, 2, or 3 certificates that you need to include, and you need to sort them if you have multiple certificates from leaf to root. So basically, the first one in the text file is your server certificate, and then all the various intermediate certificates that are required. There used to be a separate certificate chain file directive in previous versions of Apache, which only included the intermediate certificates. But I think it was always optional. You could always put this in the main file anyway, and it just caused confusion, so this was removed in a recent version of Apache. Virtual hosting, just a quick comment about that. Obviously, these days, everyone uses name-based virtual hosts. It used to be that prior to the SNI, to the so-called TLS server name indication feature being available, it was a requirement for every SSL or TLS virtual host to have their own dedicated IP address. TLS happens on a different layer, and on that layer, there's no information to the server at this point which host name or which virtual host the client wants to talk to. SNI basically adds that host name to the TLS handshake, and that allows Apache to figure out to which virtual host direct that request. One important directive I would always enable is, they're coming to interesting directive names, SSL strict SNI vhost check. If enabled, it will respond to clients who do not support SNI with a 403 forbidden response. If you set it to off or turn this feature off, a client who doesn't support SNI will be served from the first virtual host that appears in your configuration, which, unless you've set it up specifically that way, may not be the one that you want this request to go to, and again, can cause problems. So typically, unless you have specific requirements, I would always recommend to enable that setting. I mentioned Let's Encrypt earlier. They use, for their online certificate request and management protocol, they use a so-called ECMI protocol. It's a general protocol, but basically at this point, only one CA uses that, and that's Let's Encrypt. There's now a module that handles the whole certificate management details automatically. It is still experimental. It was just recently included in the latest version of Apache. And basically, if you've already configured your virtual hosts, you simply define the mdomain directive, give it the host name or host names for the virtual host for which you want to have a certificate. You simply start your Apache, and it will do the whole request or registering with Let's Encrypt, requesting a certificate, and storing it and installing it and using it automatically. If it cannot get one, it will basically serve 403 responses to request to that domain if something went wrong. Because everything's automated, you have to sign up to their terms and conditions, and you basically do this by putting a directive into your configuration that links to their terms and condition file. One directive that most people tend to ignore is a general directive called server admin. ModMD uses that email address to register with Let's Encrypt. So you should make sure that that's configured to an email address on which you actually can receive email. Because, for example, if they tell you about a new terms and conditions that you have to accept or agree to, you need to update this in your configuration. Or maybe they send you additional information about outages or changes or whatever. Let's talk about ciphers and protocols. So again, on some Linux distributions, the default configuration may look a bit different to what Apache ships with. This is the default from Apache 2.4, recent versions of Apache 2.4. There are three options that are important. SSL cipher suite, which defines the algorithms and ciphers that should be offered or allowed to be used in the server. There's SSL honor cipher order, which basically, I think Rainer mentioned it in his previous call, which basically tells the client you must obey or honor the order that the server wants you to use. Like there's a list of, this is a preferred cipher. If you don't have that, you can pick the next one, but the client has to choose one from that order. And SSL protocol is basically a higher level directive where you can enable specific protocols, SSL v3, TLS 1.1, etc., on a general level. The funny looking string that gets given to SSL Cipher Suite is basically an OpenSSL format or formatted string. That's probably one of the most, I would say, most misconfigured directives when it comes to mod SSL. It's very easy to get something wrong if you don't know exactly what you're doing, like enabling less secure ciphers in your server, etc. So if you change it, make sure you test your server after you've made the change. Often you find recommendations online with long lists of individual ciphers being defined. Here's another recommendation, which is from me basically. So this setup would ensure that in terms of SSL protocol, we've disabled everything except 1.2 and potentially 1.3 once enabled or available in the Apache. And it ensures that only high security ciphers are enabled that provide forward security. So that would be my recommendation, but again, things change with TLS, so it's always a good idea to double check these things. OpenSSL, the ciphers command from OpenSSL, you can just give it this string. I will show you a list of all the ciphers that will be enabled. It can sometimes be a bit misleading because Apache on one hand, or mod SSL on one hand, but also OpenSSL force disable certain ciphers because they wouldn't be secure at all. So the list that you get with the command line tool is not necessarily what exactly you get when you enable this in mod SSL. Ciphers are only really, or secure ciphers are only really useful or secure if you provided enough random numbers. Mod SSL has a command called SSL random seed. Again, if you use a Linux package, this is typically already being taken care of. However, it makes sure you should make sure that this is configured properly. You can define different ones for startup and during connect time in terms of random numbers. There's no default for this. Well, there is a default, but there's no default in terms of the commands itself. If you do not define it, Apache will use a very insecure built-in function to obtain random numbers. They're not recommended, or you should not use this in a production environment. Session caching, very important from a performance point of view. That's where you need this module that we talked about earlier. SSL session cache is a directive that defines the path to a file on your disk and the size of it. So the number behind this is the size in bytes. And you can define a session cache timeout. It doesn't mean that it removes the session key from the cache. It only means it defines how long the session key will be accepted as valid. A common question is, how do I define how big my session cache needs to be? You don't want it to be too big. You don't want the timeout to be too long because it has some implications on things like forward secrecy. Typically, my answer is you should calculate this yourself. You should figure out in terms of what am I trying to support with this server infrastructure anyway. A rule of thumb is that a single TLS session, when stored in the cache, takes up about 150 bytes. So if you can figure out the general numbers of your server, how many sessions in parallel, how many sessions in total you want to be able to support, you may be able to calculate an appropriate size for your setup. Initially, only session caching existed, which basically means the client stores or keeps the session key, and the server keeps the session key for a certain period of time. TLS session tickets is basically a new feature whereby the client stores the session state and the session key, and the session's key on the session state is encrypted with a master key that was created by the server. And the same so-called session ticket encryption key that the server created is used for all sessions. But the individual session key is basically stored typically in memory for each browser during a specific session. Browsers may even persist this to disk. That depends on the individual browser. So from a performance point of view, I would say, yes, it's great, you should enable this. From a security point of view, there are cases where you may not want to enable this. So there's some security, I wouldn't call it vulnerabilities, some do, I would say at least there's some security concerns when it comes to using session tickets with TLS 1.2. So we would ask me for a recommendation is, if you care or if you require forward secrecy. Forward secrecy means someone who has recorded all the traffic between a client and your server, and then at a later point is able to compromise your server, steal your encryption key, like the session ticket encryption key, would then be able to decrypt all the prior communication. If you have forward secrecy, so certain ciphers provide this, but this basically disables this forward secrecy again because it would compromise the session key. So in 1.2, if you really, from a security point of view, require forward secrecy, you should probably just disable it. At the very least, I would recommend, which is what many sites do, I think Twitter does something similar, not on a daily basis, but on a more frequent basis. They do rotate the master encryption key, the session ticket encryption key on the server side on a more frequent basis. So at the very least, I would recommend restart Apache once a day. The restart ensures that Apache rotates the key. Basically, when you start Apache and you haven't configured a specific file that it should use for the session key, for the session ticket encryption key, it will just create one in memory and hold it in memory. And as soon as you restart Apache, it will create a new one. And all previous session tickets become invalid. A graceful restart would be sufficient, yeah. So you may already do this on a daily basis anyway, doing log rotation, things like that. So keep in mind that if you do that, all the session tickets that are known to the clients will be invalid. It just means there will be a slightly higher session startup time or handshake time because it happens automatically. It will just create a new session ticket because the browser realizes, oh, my old session ticket isn't valid anymore. Let's do a full handshake and I start from scratch. TLS 1.3 resolves basically all of these issues and has certain additional security benefits. So for 1.3, recommendation is make sure you have session tickets enabled. It provides a big performance benefit. Quick one about, also related to performance in some way, not specifically, but OCSP is the so-called Online Certificate Status Protocol. Some browsers are, or at least can be configured to require OCSP, which means if I, as the browser, connect to a server, the browser would then check with the issuing CA who has issued the server certificate to check, is that certificate really still valid? Is it okay to talk to this server? And only if the CA who is required to provide this OCSP service has a proper response or a valid response, only then the client, the browser, would continue to talk to the server. OCSP stapling is a feature in Apache that you can enable. It basically is a little bit of overhead in terms of your server because your server talks to the CA and gets, CA was there, talks to the CA and gets a signed piece of data back, which is basically I think mainly the certificate serial number and additional metadata, and stores this information and then provides it to every client that connects to the server. The client is able to validate the signature because it was a piece of data signed by the CA. And after that, basically it requires, or it avoids that the client has to talk to the CA and to your server at the same time. There have been cases also with Let's Encrypt. I think it happened last year. They had an outage to the OCSP service. And for clients who are configured to require OCSP, it means they cannot talk to your site. They cannot connect to your site because the CA has screwed up. They're not providing the service. The setup avoids that or makes sure that your customers, your clients, will continue to be able to talk to your site, even if the OCSP service from the CA is unavailable for whatever reason. So again, you enable this SSL use stapling. You typically want to ignore errors from the CA. There's different options available in terms of configuring this, but typically I would recommend to turn the SSL stapling return responder errors off. Otherwise, you're just forwarding the issue to the client in terms of I can't connect to the to the CA. And again, you need the caching module to store the OCSP data from the CA. Quick one. I don't want to go into too much detail. Apache and SSL obviously allow you to configure client certificate authentication. Sometimes that's also referred to as two-way SSL. One-way SSL would be the browser is just authenticating the server, and two-way means the server is also authenticating the client itself. It's commonly or typically something you would use, or you may use, for example, in a company, you may issue certificates to your employees, and each employee would install this on their browser and be able to connect to various enterprise services in your organization and would automatically be signed in and authenticated. Also, you may have two APIs, two services, microservices, whatever you're using, talking to each other, and you could also have a client certificate there to make sure that the right service is talking to your service. The main directive to use is SSL verify client require. So you put this inside your virtual host section for which you want to require or where you are expecting client certificates. In terms of the configuration, the main thing that you need to do is you need to tell Apache for which CA certificates he is supposed to accept client certificates. So especially when it's in a company environment where you have issued certificates with your own PKI, you know this is the certificate I use to issue all these client certificates. You put this into the SSL CA certificate file, and then tell Apache this is the one or more certificates or one or more CAs that he is supposed to trust when it comes to clients coming in and authenticating clients. Again, there's a CRL file you can configure to make sure that Apache, this is actually quite important, you need to tell Apache which certificates have been revoked. Obviously, it won't accept certificates that are expired, but if there's cases where you've specifically revoked a certificate for whatever reason, that needs to be in this CRL that you need to provide to Apache, so Apache would stop accepting these certificates. Again, not going into too much detail, obviously Apache can act as a reverse proxy. It's a bit more difficult if you want to use HTTPS on the back end, because in that case Apache needs to act as a client. So you have to first of all, basically a similar set of directives like SSL engine, SSL proxy engine. You can configure the Cipher suite, the protocol, and the certificate details that it needs to be able to act as a client. One more quick one. Once you set up HTTPS on your website, if it's an end-user facing website, I would highly recommend to enable or to basically issue or include an HTTP header called strict transport security in all responses on the HTTPS port. Max age in this case basically means 1 year in this case. It's a common setup. Once you're sure that you do not want to use this host name, this website with HTTP anymore, you include this directive, and this tells browsers, or browsers basically cache this and won't use HTTP anymore. Even if someone gives them a link that points to the same host name for HTTP, it will always use HTTPS. ModMD actually provides a shortcut to this. There's a configuration option called MD require HTTPS. I think there's temporary, which is a shorter time range, and permanent, which is a 1 year max age definition. In addition to that, it also configures a redirect from the HTTP to the HTTPS website. So that's an easy way to ensure that going forward, everyone will use the HTTPS endpoint or HTTPS port for your website. How are we doing on time? 5 minutes. Time for a couple of quick questions. Anyone?
The certificate revocation file, if you change it, is it reloaded automatically? We need to reload it HTTPD.
You mean the
client.
CRL, the
Yeah.
certificate revocation file? I don't think it is not read automatically. I think, again, it requires a graceful restart for Apache to pick up the CRL. So you're talking about, where were we? This one, SSL CA revocation file. Yeah. I could be wrong. I'm 99% sure that it requires at least a graceful restart for Apache to pick up the file, to pick up a change to the file if you change it. Typically, if you, at least in the cases where I set up PKIs inside an organization, the CRL, yeah, maybe it's not something you would update that frequently anyway. There's some overhead involved in doing all this. You would update it, best case, on an hourly basis, but I've seen cases where it was just once a day, or maybe twice a day, where you would update this. Depends a bit on your security requirements. If you really need to make sure that a certificate that's revoked is reflected as soon as possible on your infrastructure, you need to increase that. If it's on a daily basis, is usually sufficient for many use cases. But I think you have to restart Apache.
Okay. In fact, we have a bug in Tomcat native which says that it didn't reload it. So I was quickly asking what HTTPD is doing. So I will probably do the same.
I may need to double check that, but yeah, I'm fairly sure you need to restart it.
I can do it too, thanks.
Okay. Any other questions? Okay, I guess everyone's ready to set up HTTPS.
All right, well, thank you all for coming to this talk. If you could all give Lars a big round of applause.